Backups via SQL Server Management Studio are so passé. Let's get our typing fingers ready and write some T-SQL. Welcome to this video on backing up SQL Server. My name is Kevin Fiesel, and I'm the proprietor of Catalaxy Services LLC, a consulting firm which specializes in work all across the data platform space, especially SQL Server. In the last two videos, we have focused a lot on using SQL Server Management Studio in order to get a feeling of how backups work and some of the basics we need to know. But I am going to lay it out for you right here. If you are a DBA and you have to use the UI to take a backup, you need to practice taking backups more often, because you can do in T-SQL everything that you can do in SSMS and more. Let's quickly head to the classroom and learn a bit more about the topic. As I mentioned before the classroom jump, I think all DBAs should know how to take and restore backups by hand. There are a couple of reasons for this. First, it's good practice at understanding what exactly is going on when you click through SSMS or Azure Data Studio. Second, being able to restore a backup by hand can serve you well in cases where the backup is located someplace you can't easily access in SSMS. SSMS is built on a fairly old Visual Studio platform, and the file selector for restoration is a custom directory tree rather than the default Windows file selector. Therefore, you might have trouble getting to network shares or other locations that don't have a pretty drive letter. Now, I should note that you can explicitly type in the network share in the menu within SSMS, but that also removes some of the point-and-clicky benefit of the tool. Third, if you are a DBA, there will come a day when you have 2 or 3 layers of management standing over your shoulder waiting for a very important database restoration. Being able to script out the command, making sure that you have the script right, and restoring the database, well, it looks really good to the people in charge. A lot better than fumbling around in the UI because you're nervous, you're trying to read everything too quickly. Now, at this point, you might say, well, hey, wouldn't it be better to have an automated system for performing backups? Absolutely, and also restorations. And, there are some free solutions that I do love. My personal preference is for Sean and Jen McCown's Minion Backup solution. This is a top-tier solution for automating backups, as it's really easy to set up for small environments, but it also works really well for big environments with complex backup scenarios and enormous databases. So yes, definitely use a tool like Minion Backup to automate your backup processes. But you still need to know how to take a backup. Now, if you look at the syntax for the backup command in SQL Server, there is a lot to show. As you can see, there's quite a bit here, and we are not going to cover all of this today, and not by any stretch. But the good news is, if this looks daunting right now, we will break it apart piece by piece over the next several videos, covering most of what I would consider important for a DBA to know. In this video, we're going to take it a little slow and work on a few fairly simple backup scenarios. So let's go to the demo and try those out. Here we are in SQL Server Management Studio, connected to my local SQL Server instance. I have a series of databases available to me, and I would like to take a backup of the Chicago parking tickets database. I will start by using the UI, but then we'll pivot to writing T-SQL. Let's right-click on the database and navigate to Tasks, and then Backup. We have some defaults here that I'm okay with. I'll take a full backup to disk in this location. For media options, let's back up to a new media set called CPT. I'll check the boxes to verify the backup and perform a checksum. Then on backup options, I'll force compression and encrypt the backup using AES-256 encryption and my backup certificate. At this point, you might be itching to hit that OK button, but we're not going to do that. Instead, I will select the script button near the top of the modal dialog. That will bring up a script in the background, so let's take a look at it. I'll select cancel because where we're going, we don't need UI. Give me a moment to perform my standard level of obsessive compulsive futzing with the script, getting things exactly the right way that I want to show them on screen. This will include a bit of extra futzing because of the query to perform validation. Nonetheless, I will eventually finish this, but in the meantime, let's at least talk about the components of this T-SQL operation. We start with a backup database command, specifying that we want to back up the Chicago parking tickets database. Next, we tell where on disk we are going to put this thing. This will go onto my D drive. or more specifically onto the server's D drive. It's just my machine happens to be the server. The next two commands, format and init, have to do with the media set. The format command says that I want to create a new media set. The init command says that I'm okay overwriting any existing backup sets in MSDB concerning this particular media set header. If you're not using a third-party tool like Minion Backup to manage backups, these settings might matter a little bit more, and you may want to dig into the SQL Server documentation to learn more about them. Like I've said in prior videos, a lot of this really has to do with going back to old-fashioned tape drives for backups, and if you're not using those, they don't necessarily matter a whole lot. But after that, I'll create a new media set named CPT, and the description on the backup follows in the name attribute. The skip command says that we will not check for backup set expiration. In other words, this backup set will never expire, which is okay. Rewind and unload are commands that only exist for tape devices, so I'll safely ignore those. Then I want to force compression by specifying that attribute. After that, I want to encrypt using AES 256-bit symmetric key encryption, using the backup certificate as the basis for this. Then I have a value of stats set to 10 and perform a checksum on the backup file. Performing a file checksum is a simple way of ensuring that what we wrote to disk is what we expected and there were no errors along the way. That's the backup statement itself. The rest of this query is what SQL Server Management Studio used to verify that the backup ran successfully. First, we check to see if the backup set is in MSDB. If not, throw an error. Then we restore the database from disk with verify only. This does not actually perform restoration, nor does it perform any actual checks on the data. What it does is ensure that the entire backup is readable and the backup set is complete. Now that I've explained it, let's give this a run. Switching to the Messages tab, we see an update for every 10% of the backup processed. That's what stats equals 10 does for us. The backup itself will probably take somewhere around 20 to 30 seconds, given that I'm currently recording and databases are notoriously shy creatures. Nonetheless, once the backup completes, we'll begin the process of verifying the backup. That won't take as much time as backing it up, though it does require that we scan through the file, so this will depend on the size of your backup and how fast your underlying storage is. Eventually, verification will complete as well, and we'll get a message saying that the backup set is valid, so hooray for us. Now let's do a bit of experimentation. First up, I'm going to change the disk setting. It turns out that there is a special setting on disk called null, with one L, so it's not as bad as null, I suppose. Let's perform that swap, replacing the drive information after the disk command with null. Note the single quotes here. I'm also going to delete the verification code as we won't have anything to verify. One last thing before we kick off the backup. I want to make sure that this is a copy-only backup. To do so in T-SQL is easy. You add the copy_only attribute. Once that's on, we can back up the device, safe in the knowledge that this is a full backup that will not break our log chain. Granted, the Chicago parking tickets database is in simple recovery model, so this actually has no practical impact, but it is a good habit to get into, especially when you start working on systems where most or all of the databases are in the full or at least bulk logged recovery model. Okay, back to null. Null is a special device, like I mentioned. It basically indicates that we are going to read the data from disk and pretend to back it up, but we aren't actually writing it anywhere. In Linux terms, this would be /dev/null. Similar idea. So this way, we can understand the time cost of writing to our particular storage mechanism versus an ideal where it takes 0 time to write to disk. Let's let this run again, and we can see that it will take less time to finish. Some of the difference in performance is that I'm backing up to the same disk as where the data lives, which is typically a backup no-no, not only for performance reasons, but also because you run the risk of the disk dying and losing both your database and the backup. Backup performance is a topic of a future video, but I figured I would show this off right now to wet your whistle, so to speak. Now, let's see how the backup chain works by taking a few backups. Chicago parking tickets won't be a great example of this as it is in simple recovery model. Yeah, I could simply change the recovery model, but what's the fun in that? Instead, let me introduce you to the Analyzing Biz Data database. a simple database that I put together for a presentation on analyzing business data with T-SQL. By the way, that's going to be a future series, so if you're keeping track of the channel lore, feel free to update the wiki. Let's change this backup command to do what we need to do. I'll change the database to analyzing biz data, and then switch disk from null to a backup location on my J drive. I'll change the media name to ABD and the backup name to ABD-full database backup. I'm also going to remove copy only because we actually want to reset the log chain with this full backup. I'll kick off this full database backup and it will finish quickly. This is a small database. It's only about a megabyte in size, but that's all I need for my work here. Now let's take a differential backup. Remember that a differential backup covers all changed pages since the last full backup. I'll take the command and paste it in. Let's analyze the difference between taking a full and a differential backup. First up, we can see with differential. Well, this is the primary difference for us, as it indicates the type of backup. The default is full, so we didn't need to specify it then. Next, we're saying we do not want to format or initialize the media set, so I don't need to specify a new media set name here. I did change the name of the backup for the sake of politeness to differential database backup, but it didn't matter. The rest of our commands are the same. Let's kick this off and we'll see that it too finishes quickly. Switching back to Windows Explorer for a moment, we can see that this differential backup is tiny, just 80 kilobytes. That's because I don't actually have any changes. So let's go ahead and make some changes. I have here a table called dbo.toy. I am going to generate 10,001 rows of artificial data in it. This command, by the way, makes use of generate series. It's a new function in SQL Server 2022 that builds out a sequence on the fly. In order to use it, you have to be using SQL Server 2022 and be in a database that is in SQL Server 2022 compatibility mode. I'll run the command and that will load 10,001 records. Now let's switch back to the backup database script. I'll do a couple of things here. First, let's take a transaction log backup. We can see that instead of backup database, the command is backup log. I've also changed the extension of the log backup to .trn. Now, there's nothing special about using .bak for full backups or .dif for differentials or .trn for transaction log backups, though you will see people often will use these or similar extensions. SQL Server doesn't actually care what your extension is, so the extension is entirely so that you can remember what type of backup this is. Or you could go full chaotic neutral and make all of the backups end in .back. If I take a peek at these backup files, I can see that my transaction log backup is here. I now have a chain that moves from a full backup to a differential backup to a log file backup. I need all three of these if I want to get to point-in-time recovery. But let's add some more records to the toy table. It's just a heap with no constraints, so I'll simply rerun the script and add another 10,001 rows. I now have 20,002 records in this table, which means it's time for another differential backup. I'll change the name of that differential backup to analyzingbizdata_2.diff and kick off that script again. Once again, we have a differential backup in place. We can see that there is this new differential backup. It is smaller than my full backup, but only by a little bit. If I keep adding more and more rows to the toy table, this will eventually no longer be true. At some point, my differential backup size will exceed my full backup size. But let's not think about that too much right now. Instead, let's think about the transaction log. Taking a differential backup does not mark segments in the transaction log as backed up, so I still need to take a transaction log backup at some point. Let's do that now, remembering first to change the name of the backup to end with the number 2 instead of 1. There. Now I've processed these transaction log pages and have everything written to disk. We have another transaction log backup file, and it's roughly the same size as our first transaction log backup. Okay, we've taken a transaction log backup and everything is good. Now let's take another transaction log backup, making sure to increment the file name so that I don't accidentally keep two transaction log backups in the same file. That won't actually break anything, but I do like to have different names for each transaction log file. Though, honestly, I could actually see the benefit of having a single transaction log file per full plus differential combination, making it easier to restore from disk later on. That, however, is a discussion for a future video. We are currently still backing things up, not yet trying to restore them. Let's go back to Windows Explorer one more time so that I can take us through the log chain. Everything here starts with analyzing bizdata.back, my full backup. From there, I can perform point-in-time recovery. If I want to restore to some point after my first differential backup, but before my second, I'm going to need analyzing bizdata.back, analyzing bizdata_1.diff, and analyzing bizdata_1.trn. If I want to recover to some point after my second differential backup, I need analyzing bizdata.back, analyzing bizdata_2.diff, and at least analyzing bizdata_2.trn. If I want a point in time after that, I will also need analyzing bizdata_3.trn. But note that I don't need the first differential backup or the first transaction log backup. The second differential backup actually covers everything up to that point. So let me do one last thing in this video, and that is backing up to a share drive. Let's say that instead of the J drive, I want to back up to a share location on a server. This is pretty easy to do, assuming that your SQL Server service account has write permissions on that share. In this case, I'll use share notation, starting with 2 backslashes, then the server name, and then the share file path. I have a remote server called my server name, and it has a share called SQL, inside of which is a folder called backups. I can write my backups into there. Again, assuming that permissions are correct for the service account. So let me show you what happens when permissions are not correct. I will paste in a command that I expect to work because it is a share on my own computer. In this case, my SQL Server service is running as a sudo account, ntservice /MS-SQL Server. That sudo account does not have permissions to write to the share. Therefore, we get an operating system error that access is denied. But don't panic, we can fix this. In my network section, I have a share folder for R9. Let's right-click on it and go to Properties. In here, I'll switch to the Security tab. We can see that I've actually given that MS SQL Server sudo account some permissions, but that they do not include write. I'll change that now. First, let's select the Edit button. On here, I do have MS SQL Server, but let's say that you don't have it at all. Let me show you how you can add the account. I'll select the Add button next. In here, my object type is users, groups, or built-in security principals. I need to type in nt/service /MS SQL Server. If I leave off the NT service part, Windows won't be able to find that account. Then I can select OK. At this point, I'm able to grant specific permissions, and I will give it the right permission. Now I'll select OK a couple of times until I'm back in Windows Explorer. Let me see if that worked. I'll run the backup script again. Hey, it worked just fine. Now let's go back to the share location and we can see that transaction log backup. This shows that we did, in fact, write the transaction log file out to disk. And there you have it. Taking a backup in T-SQL is pretty easy. Granted, I'm also obscuring many of the complexities you can run into with backups, and I haven't even touched on restoration yet. But don't worry, we will spend quite a bit of time on restoring databases and then handling some of the more complex backup and restoration scenarios. In the next video, we are going to use a totally different language to take backups. I'll let you take a wild guess at what that language will be. Leave it in the comments if you want. We'll have links and show notes in the description below. And until we see each other in the next video, take care.